Hi guys, welcome back to my mathematics tutorial again. My name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So in today's lesson, we want to look at some problems involving derivatives of trigonometric functions. In the previous lesson, we derived the trigonometric identities from the first two identities. We were able to derive the rest of the four other trigonometric identities using the quotient rule of differentiation. So remember that in our previous lesson, we did the derivatives of these functions using the first principle of derivatives. So if you wish to know how to find these derivatives using the first principle, you can visit those videos and watch them. So I want to solve some problems, starting with some babies problems, some babies, just some little problems. So remember the rule, whenever you differentiate a trig function, you must differentiate the angle. That's the golden rule of finding derivatives of trigonometric functions. Differentiate the function and differentiate the angle of the function. So first one, y equals the sine of 2x. So the first thing that should run to your mind, what is the derivative of sine of just x? Or sine of just an angle? Assume that this 2x is just representing x. So what is the derivative of sine of that x? So the derivative of sine of x, we know that is cos of x. So the derivative of, this is x, this whole thing is representing our x. So the derivative now of this sine of 2x, y prime is equals to cos of this 2x times the derivative of 2x, that is x prime. So then we differentiate this 2x. The derivative of 2x is just equal to 2. So y prime is just 2 cos of 2x. So we're done with the first one. You see how easy it is? Very, very easy. Now, the next one says secant or sec of 3x squared. So y prime equals, what is the derivative of sec? Derivative of sec is sec x tan x, or secant x tangent x, right? So we say secant x. But what is x? This whole thing is representing x. So it's secant of 3x squared times tangent of 3x squared. Then the next thing is that for us to differentiate the angle. So what is the derivative of this 3x squared? So we say 2 times 3 is 6. X, we subtract 1 from this power, is just 1. So we've now differentiated the trigonometric function secant of 3x squared. So we can simplify this. 6x come behind. You don't multiply this 6x by the angle. So y prime equals to 6x secant of 3x squared tangent of 3x squared. So we're done with this. Let's move to the next one. Y equals to tangent. Now, tangent square x over 2 can be rewritten as tangent of x over 2 all squared. Then we can use the power rule. Remember, the rule says if y is equal to x raised to the power n, y prime is equals to n. Bring this n down, and then you rewrite x and say n minus 1. So what is our n? Our x right here. Our x here is this tangent of x over 2. Our n now is this 2. So y prime equals n, which is 2. We bring this 2 down. We rewrite this x, which is tangent now of x over 2. We subtract 1 from this power. So we just be 1 times the derivative now of this particular angle. We know, we told you whenever you differentiate a trig function, you must differentiate the angle. So what is the derivative of x over 2? Now remember, x over 2 is the same as 1 over 2 times this x. So this 1 over 2 is just like the coefficient of this x. So what is the derivative of x? The derivative of x is just 1. So times 1 over 2. So this gives us 1 over 2. So this 2 down here, what happens? You cancel this 2. So y prime now equals to tangent of x over 2. Let's solve additional problem. So another problem says y equals to cos square x square plus 1. So this is the angle. So what if we had this problem? Y is equal to cos square of x square plus 1. So the derivative now of cos is just negative sine. So we can first rewrite this in exponent form. So we have cos. Now this square will come over the whole thing. And then this square root now can be changed to 1 over 2 to exponent. So it's x squared plus 1. So now what do? We differentiate using the power rule, or we call it the standard power rule, because we have to differentiate inside. So we bring this power down. So y prime equals to 2. We rewrite this expression, cos of x squared plus 1 raised to the power 1 over 2 times the derivative of cos of what is within here. This expression, right? So what is the derivative of cos? The derivative of cos is minus. So that is minus sine square, so it's sine of x squared plus 1 raised to the power half. Remember, it is the same angle you are using times the derivative of the angle. So what is the derivative of the angle? The derivative of this angle now is 1 over 2. We bring this power down. We rewrite x squared plus 1. If we subtract 1 from within half, we get negative 1 over 2 times the derivative of within side. So x squared is just 2x. Derivative of 1 is 0. Now we have differentiated. Let's simplify. So y prime now becomes 2. Now remember that this whole thing, this entire thing is just one term, right? Now this carry this out. This whole thing is just one term. So we have negative, and this is x. X comes at the back. So this is also 2. So it's 2x. So we have cos of x squared plus 1 raised to the power 1 over 2 sine of x squared plus 1 raised to the power 1 over 2. This x squared plus 1 raised to the negative half, we can send it within the denominator, it becomes positive half. Now, after you have differentiated, another thing you need to do to further simplify the derivative of the trigonometric function is to bring in some trigonometric identities. That's what I told you. You must master the identities. Now we know that sine of 2x, the double angle identity, is equals to 2 sine of x cos of x. Now, this looks similar to this. If this 2 can be placed right here, you understand that we have 2. Now, this 2 sine of x cos of x is also 2 cos of x sine of x. Remember, sine of 2x. So this is 2 cos of x times sine of x. So our x here now is representing the square root of x squared plus 1. So therefore, we can now say y prime equals minus x. What is this whole thing? So this is now sine of 2x. But what is x? X is this angle. So it's now x squared plus 1. Now we can use the square root instead of half. Square root. So it's 2 the square root of x squared plus 1. Or divided by, we can also use the square root down here, x squared plus 1. So this is our final answer for this problem. Y prime equals to negative x sine of 2 the square root of x squared plus 1 divided by x squared the square root of x squared plus 1. So this is how we find derivatives of trigonometric functions. In the next lesson, we will solve more problems on finding the derivatives of the trigonometric function. Thanks so much for watching, and see you in our next lesson. Thank you.